Welcome back. In the last video, we learned how rectifiers convert AC into pulsating DC. But pulsating DC is not good enough for most of the electric circuits, right? So today we take the next powerful steps, which is the filters. So the heart of smooth DC generation. So today we will see how the filters turn unidirectional AC into a smooth DC. So let's move ahead. So the rectifier gives us DC, but not clean DC. It has ripples, right, as we have discussed in our last class. So rectifier gives us unidirectional AC signals. So those can be full wave rectifiers or half wave rectifiers, but these are not DC signals, right? So this has ripples, means variation of the waveforms. So these variations or the ripples are to be converted into a DC signal. Filters are used to remove these ripples and produce a steady smooth DC suitable for radios, chargers, sensors, digital circuits, and in fact in everything. So how these filters work? So these filters don't magically delete the AC, right? So they oppose charges in voltage or current depending on their nature. So for example, inductors oppose the rapid change in current, whereas capacitors oppose rapid changes in voltage. So by combining these two properties, we shape the output to remove these ripples. So this is why filters always sit immediately after a rectifier. So let's move ahead. So first one is the inductor filters. So an inductor filters is simply an inductor connected in series with the load, because inductors reject sudden change in current, so the ripple currents get suppressed while DC flows easily. So the inductor behaves like a current smoother. So as you can see in this waveform. So best used when the load draws high current like motors and power supplies. So the unidirectional AC signals will get converted into a smooth filtered output as shown here. But while working with inductor filters, although we are controlling the current, but the voltage that we are getting or the amplitude that we are getting is slightly less than the maximum value. So in order to retain this maximum value or to generate the filters to obtain the maximum amount of voltage, we have to go for the second option, which is called as the capacitor filters. So here we have different advantages in the inductor filters as mentioned here. So like low peak current through the rectifier diodes. So we have output voltage which is zero point 0.9, which is less than the total value multiplied by VRMS, and reduce stress on the rectifier components. And practically the drawbacks of using these inductor filters are they are physically bulky, higher in cost, poor regulation at lighter loads, requires continuous rectifier conduction. So we can go for these choke filters whenever our requirement is with higher loads. Now moving ahead, next is capacitor filter. So in a capacitor filter, a capacitor is placed in parallel with the load, as you can see it here. So here the capacitor charges up to the peak, as you can see in this waveform. It charges to the peak and then discharges slowly through the gaps. That means, as we know, the charging and discharging time of capacitors are different. That means the capacitor gets charged instantly and the discharging time of the capacitor is quite high compared to the charging time. So until and unless the capacitor discharges, the next waveform starts, and whenever the next waveform starts, the capacitor charges again. So giving rise to this type of waveform. So this is shown in a half wave rectifier. So if the condition is for full wave rectification, then the output will be like this. Okay, so it behaves like a voltage reservoir, reducing the ripple voltages. So here one example is given for a full wave rectifier at 50 hertz, for FR given as 100 hertz with a load at 100 milliampere. Matha, delete everything. So here the base application is like to moderate loads where we require high DC voltages with acceptable ripple levels. So now as we have understood both the capacitor and inductor filter, now let's see how to get advantage of both of them. So next filter is LC or L section filters. So here we combine the strength of both inductor and capacitor. So this is the classic LC filter or choke input filter, where the inductor first smooths the current and the capacitor smooths the voltage. So these are used in power supplies that need better ripple reduction than a single element that can provide. So this gives cleaner DC, either L only or C only can provide. So first inductor will smooth the signal and then capacitor will reduce the ripple further. So this is the application of LC filter. So depending on your requirement, you can generate the filter as we require. Now moving ahead, next is multiple L section filter. So it is nothing but combination of L section filters or LC filters, means increasing the number of stages. So as we are increasing the number of stages, the reduction of ripple will be more, and depending on our requirement and setting out the number of sections, we can generate DC signals directly across the output. So as we have discussed or we have just pointed out, so when extremely clean DC is required, we have this multiple L section filters. So think of as taking multiple cleaning stages where LC stages removes leftover ripples from the previous stage. So these filters are used mostly in audio equipments, communication receivers, and sensitive analog circuits. They have extremely high ripple attenuation, and each stage multiplies attenuation factor, and ideally for precision instrumentation. And they are excellent for the sensitive analog circuits. So these are multiple L section filters. So now next moving ahead, if you want to determine the maximum value of voltage, that means the peak of the input should be retained in the filtered output, then we have to go for another type of filter which is known as capacitor input filters or also known as pi filters. So as you can see here in this diagram, so this is very popular pi filter because it looks like the Greek letter pi. So a capacitor first smooths the voltage, then the inductor removes the ripple current, and another capacitor finishes the job. So these are excellent in removing high frequency and low frequency ripple components. Right. So now as we have discussed all the filters that we can build using inductor, capacitor or combination of both. But one drawback is there which we have already discussed in first inductor filter, that they are bulky and then they are very much costlier. Whenever we are introducing inductor in the filter, then it becomes costlier and also it is bulky. So in order to get rid of that, we have the option for RC filters. So finally, when the cost must be low or load current is very small, then we use these RC filters. So resistor plus capacitor is simple and inexpensive. So not as efficient as LC filters, but excellent for small signal circuits. So these are the all different configurations for the filters. So if we go for the summary, so the goal of our today's class is very simple, converting pulsating DC into a smooth DC. So for which we have inductor filters with smooth current, capacitor filter with smooth voltage, LC filters or multiple LC filters with high quality of DC, and next we have discussed pi filter which are excellent in overall performances, and finally we have discussed the RC filters for economic or small loads. So in the next video we would try to move ahead and discuss with the passive filters and how we can deal with the passive filters for filtering different frequencies of the signals. That means, like suppose if you want to remove a particular frequency range, so how we can remove that from a AC signal, that we are going to discuss next. So I hope today's class helped you to understand the filters like never before. So give a thumbs up, share with a friend, and drop your doubts in the comment. I always reply and you will get your questions cleared at the instant. So see you in the next class. So here I have provided some design checklist for the PSpice simulation steps. So just try these steps and try to implement the filters using PSpice. So thank you for joining. Keep learning.